Hello everyone, welcome to the section on vectors. So from this section we are going to learn about a new data structure, and further on we will discuss more data structures. And what are vectors? We will talk about vectors, but first let's see why vectors are needed. Okay, we till now we have worked with arrays, but arrays have a problem. The problem is if you don't create a dynamic array, then the size of the array is fixed, and suppose you initially estimated there would be only 100 inputs, but later on you realized you need to expand the array, okay, because more number of inputs are given by the user. So vectors help us to solve this problem by creating dynamic arrays internally. So vectors are what they are called, the sequence containers. So when we talk about C++ standard template library, you will often hear this word container. So container is nothing. A container represents a data structure. Okay, so vector is a container, and it is a data structure. Okay, so we will talk about little bit about STL from the next lecture also. So what is STL? STL stands for Standard Template Library of C++. Okay, so every language like Java, Python, they have their own implementations of all the common data structures. And one thing we can do is, if you're a beginner, it is important that we understand how a data structure is implemented. Okay, so the focus of this section would be how this is implemented, and second is in problem solving. If the question does not ask you to implement the data structure, so most of the times you have to use the data structure. Okay, so this part, how to use the data structure, it is important when you are solving problems, but how a data structure is implemented, it is important to understand the fundamentals of data structures. Okay, so we will cover the how part, and we will also see some examples of how to use vector while solving a problem. This standard template library gives you inbuilt vector so that you can directly use in the problems. But what we will do, we will first see how to use the vector class that is provided by C++ standard template library, and second we will build our own header file to simulate the same data structure, and at that point we will dive deep into the implementation of a vector. Okay, so we will do both: how to implement a data structure, how to use inbuilt data structure, and how to use the data structure that you have implemented. Okay, so that's the whole goal of this section. So let's talk a little bit about vectors. So vectors are sequence containers. So as I said, what is a container? Container is a data structure. Sequence container means it stores items in a sequence like an array. Okay, so they are nothing but they are like arrays that can change in size. Okay, so if a vector is full, it can grow itself to accommodate more number of elements. Okay, so this is a special thing about a vector, and they use continuous storage locations. So if it is a vector of integers, and we know each integer takes 4 bytes, so if the first box is at 100 address, the next would be at 104, 108, 112, and so on. Okay, that means they occupy a constant memory, and if this is the case, we can access each element in O1 time. So if I write, okay, tell me what is at the third index of this particular vector, so 0, 1, 2, 3. Now you may ask, how do we reach this address? Okay, so as I discussed earlier, so this operation is broken down by the compiler as star of v plus 3. So v is the base address. Okay, so with v, we know the base address of the vector. Let's say this address is 100. Okay, so this address is stored in a special kind of a table that is generated by a compiler. It is known as symbol table, and it is a read-only table. So all the variables that you create, int x, int array, all the addresses are stored in a symbol table, and from that we get to know, okay, this address is 100, and plus 3 basically means if it is a vector of integers, we will multiply it with 4, so we will reach this location 112. So this is a order 1 operation. That means we can directly reach this location, this address, and find out where the value is present. Okay, but unlike arrays, their size can change dynamically with the storage being handled by the container. Okay, so the idea of this section is to dive deep into how the storage is handled and how vector grows by itself, and we will implement the same functionality using our code as well. Okay, so sounds interesting. So we are going to see vectors from the next lecture. So first I will show you how to use it, and then I will show you how to implement it. Okay, so we will follow a reverse order, because once you get an idea, okay, this is how I use a vector, these are the functions that vector supports, then we can think of the logic how we can implement such a functionality, and we will build our own vector class, and we will build a header file. Okay, so that you can include this header file to build your own library of data structures. Okay, once you know how to build header files, you can build your own library of all data structures after completing this course, including hash tables, priority queues, linked list, anything you can build. Okay, so that's all for this introduction. Let's see vectors demo next.